One of the primary differences between a relational database and a document database is the way you model your data. In a relational database, there are well-known patterns that are called normal forms. The aim is to reduce duplication to make sure that you record a piece of data once. The downside is when you need to actually check where that data is. It becomes a lot harder to track because you may have to go through multiple hoops to do so. A document database model, coupled with special features in RavenDB, effectively handle many of the challenges relational databases force upon you and make your life a lot easier. There are many ways that you can model your data with RavenDB using attachments, counters, and time series. RavenDB is built so you can even model your data using indexes. Today, RavenDB CEO Oren Aney shows you how to model your data with the next generation of database. You will learn how relational databases are modeled, the challenges these databases present developers, how you can use RavenDB to model your data, taking advantage of indexes, time series, attachments, and other features to model your data. Feel free to ask questions by clicking the Q&A button at the bottom of your screen, and Oren will be happy to answer them throughout the session. Enjoy your presentation, and here's Oren.
Hi everyone, thanks for coming for this webinar. And this webinar is something that I actually already done. I've done many discussions and sessions and conference speaking engagements about modeling complex data structures. And I would really love it. We have quite a few people online ask questions. Online directly, it would be much easier and nicer for me if you ask questions and interact, because this whole scenario is about talking about non-trivial examples. Now, the issue with that is that whenever we talk about modeling, the thing that keeps popping up is Northwind and the online shop, and this is annoying, really annoying to me. It's not that interesting a model. So let's look at something that's a lot more fun. A game. A game is fun. Well, by definition, a game should be fun, or else it's a bad game. So here you have something from a D&D or something similar to that, and look at the data for a while and try to imagine how you would model something like that. There is a lot of data here, and for almost everything here, you actually have multiple interesting details that you have to deal with. For example, the armor class is composed of the armor that you have, which has multiple items. For dexterity, strength, all of those are impacted by buffs that you have or debuffs. They're impacted by equipment that you have, all sorts of modifiers, whole bunch of other stuff. So how are you going to model something like that? How are you going to think about something like that? So let's look at this. We have this example, this Dagger of Venom. It looks like a very cool dagger. And let's try to decompose everything that we have here from here to something that is meaningful. And you can see that we have the type of the knife and where it can go and all much of other stuff. But notice that the richness of the model. So the first thing that we have to understand is that it's very tempting to go and start building inheritance hierarchies. The problem here is that inheritance hierarchy in this case would be the absolutely wrong thing to have. Why is that? Because the inheritance model, something like that, are generally things that are amenable for developers to work with. But in many cases, when building a game or building the game engine, you have the developers who build the engine, and then you have the designer, the content creators that actually create the story, create the actual environment, and they have arguably a more important role in the game design. So the role of the developer here is to give them as much freedom as possible while not constraining them. At the same time, if we're talking about non-trivial examples, then how am I going to store all of that information in a way that makes sense, that make it easy for the user to work with? And the answer is simple. We're going to use a whole lot of tables. I actually taken that from this GitHub project. And this is a simple, it says so right there, example of how you're going to represent a character using SQL. 48 tables. Notice that you have the characters, then you have status effects, and then it goes to the status effects ID. But the status effects has a timestamp. It probably also should have a whole bunch of other things as well, and it gets crazy. Now, this isn't that bad. The schema isn't the problem. The problem is, how am I going to go and show you this? Try to imagine how many queries I'm going to need and how costly that's going to be. The problem is at this point, the database technology that we use is now so much harder to utilize than what we would expect, which means in the end that either we're going to work with very small structures, or we're going to force the content creators to understand that, oh, this is expensive, don't do that. So one of the advantages of RavenDB is that you can take all of this and just serialize directly into a complex object, because RavenDB has no issue with complex object graphs. But that leads us to an interesting problem. Okay, so I can model everything as a object graph, serialize all of that to JSON. But how am I actually going to build the system? Because this doesn't make sense. I mean, I'm not going to have to repeat everything all the time. So the typical way to handle that is to use something like the templated instance models. So we have this thing. This is the template of a knife. And you can see that this is still very much a small thing. It's not really that interesting. But it holds all of the relevant details, including things such as the modifiers that we will use to generate that, a bunch of other stuff. And then when we need to create an instance of this, we apply whatever random generation we want to generate the actual instance of this item. Now, the idea here is that, and again, think about the content creator, the person who is going to have to work with that. And the idea here is that you give them the rough shape of the system, and then you're going to start applying additional behaviors. So, okay, you start from, okay, you want to create a knife. Here is the knife based on this template. And you can just hit random until you get the results that you want for the story that you're building. Or you can start modifying that from the template. Now you can start saying, okay, I want to add another damage type against orcs, and that, or against goblins. That would give us Bilbo's sword from Lord of the Rings or The Hobbit. I can start making things more and more interesting. Now, the problem here is that this is the data. This doesn't help us to actually operate on things. So now we have a question, how are we actually going to work with this data? Now, to be fair, I want to make sure that I'm not actually going to go into the details of let's build an RPG game. That's sadly out of scope. It's probably a fun project, but out of scope for this webinar. But I do want to focus on the implications of what we're doing. And here is how we can get all of the status effects that we have on a particular character. And you can see here that the status effects that we have here is literally just the status effects of that come from all of the equipment that we have. Maybe I have to add here a buff, debuff, all sort of stuff like that. But now I have a very simple way of saying, okay, given this property, let's list the effects on the characters, and now we can compute various things based on that. Now, this is important because how does this relate to a database? What does it mean? And the answer is, think about what would be the impact of something like that if you're not using a RavenDB. Because in this case, we know that the cost of accessing the main-end weapon is effectively null, because this is part of the same document. It was already loaded. If I was trying to do that in a relational database, that would be horrendously expensive because each one of those would be a separate query. And I made my living optimizing these sort of things. That's not fun. So we need to think about how to handle that, how to manage this. And that's something that is sadly quite complex in relational databases and something that you just never think about when you're working with RavenDB. Now, that leads us to another issue. What's going to be the size of my documents using this model? Because I'm actually going to have to create this. And if any of you ever play D&D, you know that the character list can go quite big. Now, quite big in terms of pen and paper is not that interesting. Because, okay, it would be 2 kilobyte, 3 kilobyte, no worries. But if we are starting to put more and more items, more and more data into the character, it may grow quite large. This is especially true if we start putting things such as the action log. So we do need to consider about the model. What are the aspects of the characters that are bound to it? What is the current equipment? What is the current buffs? Those sort of things. On the other hand, the quest log is a separate entity, which would reside in a different document. In the same sense, the action log, the combat log, all of those sort of things, anything that is natively unbounded is going to reside in a separate location. I hope this makes sense. I intentionally started with something that is quite complex, and I'm diving directly into that. Oh, we have a question from Eliran. I would like to know more about correct patterns or recommended with modeling data and using RavenDB. And congrats on the D&D examples. Okay, so the 3 very important aspects of modeling RavenDB. You want to be coherent, isolated, and there is coherency, isolation, and there is another thing that I'm losing. So I will cheat and I will go and look at the book and quote you from there. So this is unfortunately, here we go, coherent. Oh, here we go. Independent, isolated, and coherent. So those are the 3 most important factors, those things. Now, let's talk about what it means. Independent means that I can write to this document independently of everything else. This mostly impacts write. A good example of non-independent item in this case would be the main hand. Technically speaking, I could do something like what is name? Bill. So this would be name Bilbo Baggins. So this would be a separate document. Now, this doesn't make sense. This is typically how you would model that in a relational database, but this is very much against best practices when we use RavenDB. You want to model things so each document is independent, is coherent on its own. The jewelry, the one ring on finger number 3, this is not coherent. You have to put it here in order to make sure that it's coherent. So now you know, in this case, Bilbo is invisible. Debuff, corruption of spirit, stuff like that. Maybe I'm reading too much fantasy recently. Anyway, so that's one aspect of this. The independence and coherency of the system. Isolation means that, again, all of that comes to all of that comes, so Eliran is saying no such thing as too much fantasy or science fiction. I will tell you that this 2020 has been a really horrible science fiction session, which I would much rather would end very quickly. Global plague and all sort of other stuff that happened this year is just too crazy. Anyway, so coming back to modeling and isolation. Basically, the idea of modeling RavenDB is simple. I want to be able to look at the document and it should make sense to me. Now, in many cases, you have associated data. The quest log, the combat log are a good example of that. But it may be, again, going to the D&D, you may have the party. So you have now you have Bilbo and Gandalf, and I don't remember the other guys. So the idea here is that, okay, now I have a party, and the party is composed of people, and those are independent documents. The easiest thing to ask yourself is, does it make sense to refer to them independently? And in this case, if I can split the party, then the members of the party are independent and should be on different documents. Hopefully it makes sense. And this is the number one aspect of modeling RavenDB, just selecting the appropriate granularity. Notice, by the way, that in here, this is marked with JSON ignore. And this is quite intentional. Why do I have it in this way? Because this is a transient operation. Every time that I load the document, every time that I access these effects, I want it to be applied again. So there is no point for me to persist it to the database. Now, alternatively, it may be that this is something that I want, that depends on how your model is built. For example, if you need to run searches on, okay, give me everyone who has a particular, I don't know, vulnerability to Sauron. And I want to be able to, and Sauron is casting magic, and now I need to find all of the characters that are vulnerable to this thing and do something with that. At that point, I would need it to be persisted, so I would be able to query on that. Alternatively, I may want to compute that during indexing time. For that matter, another consideration that we have to take into account is that I may not always want to work with a full document, especially if I have big documents. For example, if I'm looking at the party screen. So one way for me to do that from parties where this is one way for me to handle this. To say, okay, give me all of the associated member in the party. This is one query to the database. Great, that's perfect. But if I have a large party or large documents, this may be something that I don't want to do. In which case, I may want to do something like that. Now, I'm going to do something like this is the character. And things of this nature. So what this would do, it would load just the relevant fields that I want and send them back to the user. Now, this is more advanced. This is stuff that you do as the second thing, but just something to consider. Now, let's talk about more complicated scenarios. Let's talk about how I'm actually going to handle operations in this game. So I mentioned earlier, I want to emphasize entity component system. This is the typical model that you use. This is all of this object graph and operation that you have. And the idea here that in terms of the operation that you're doing, each document is an entity, and then there may be action that an entity can take. A character may attack, a trap may be triggered, those sort of things. And then you have, oh, this is attach instead of attack. Sorry about that. But then you have, okay, here is the behavior. We have attack that does X, does Y. And the idea here is that a lot of that depend on the level of dynamicism that you want to have. And in many games, you want to have a lot of dynamicism, a lot of opportunity to inject different behavior, because that makes the work of the content creator easier. In many cases, a lot of the actual game logic is pushed into scripts. And in games, a lot of time use something like Lua, and this is Lua code. And in this case, you can see that, okay, what I want to do, I want as much as possible to make things generic, and then pass the responsibility of the actual actions down as much as possible. And in this case, you can see I have an evil knife that if the target is not evil, we add unholy damage. And if the owner is not evil, then we might take reflected damage as well. Now, a lot of that is about the complexity of the system. And you need to consider how to handle that. But notice that the generic part of the system become its own problem. Why is that? Because I'm going to need to do dynamic fields because I have to store data for scripts like this. I'm going to have to store complex structures. All of those sort of things make it very hard for the developers if you're using something that isn't a document database, something that is different than RavenDB. And with RavenDB, a lot of the dynamic stuff it just works. You don't really have to think about that. And here is a good example of how this can look like. Now, notice that in this case, I actually have the script right there inline. And which means that as the designer, I can go and define all sorts of actions that would happen. And I'm sure that you can imagine how that would work. And now, This is what I have to talk about games, and it actually started with the team that I think is farthest away from the typical business application that I usually talk about. If you have any questions about if you have any questions about games, now is the time before I move to the next model. Or if you have additional models that you want me to talk about and things of this nature. If not, we'll have more times afterward, but I would really love any questions that you have. Okay. So I got the questions from, we have Alex. The party example, where you have multiple parties and characters being able to be part of multiple parties. How would you model that in the references? And let's talk about that. So I had, here we go. So if you look at this, we have the notion of members. So a lot of that depends on how that works. We may have members. If I'm building stuff like this, it is absolutely valid for you to have a many-to-many association. How? By just doing this. So now Bilbo is part of two separate parties. Now, for the party example, I would argue that this is the case. Party may have from 2 past members, all bunch of other stuff like that that you might want to have, but it is absolutely valid for you to say, okay, I was in this party and then I left and joined another party and stuff like that. Now, a lot of that depends on the game logic. If the game logic says that you're only allowed to be on one party at a time, then the appropriate model would be to do something like this. Parties, not parasites. Now, what's the difference between this and this? By the way, even if we have this, we probably should want to have this, if only to record past event, because I was at this party, those sort of things. The other thing that is important is to consider whatever the party as an entity has its own behavior. And in many cases, that's the case. You may have things like party quests. You may have things like a buff that apply to the party and not just to the individual people. So a lot of those things are quite interesting and things that you have to take into account. Moving to the more generic system, many-to-many is easy, as you can see right here. But we have to also consider where do we place the association. For example, if we have past parties here, I don't think this is a good idea. Why is that? Because this is actually something that may grow unbounded. Do I actually care to have the IDs of all of those previous parties? I don't know. I don't think so. So that's something that we want to take into account. We want to consider what are the impact of modernism here. Typically, party has a limit of the number of members. And past members may be that we're going to say, okay, we're going to do something like this. So now this is a past member. And if you went by the limit of the party, then you cannot add more people to this party. You have to disband it and create a new one, those sort of things. just some of the things that you have to take into account from a modeling perspective when you design the system. Okay, now let's go back here and discuss the idea of documents in the sense of searching across all sorts of interesting documents. Now, in this case, we have a polymorphic issue. We have the notion of a document base, and we want to search across all of those things. I may want to have a room rental or year lease or stuff like that. And I want to search on that. The typical way you will model that is here is the yearly rental, and here is the room rental. You notice that there are things such as kitchen access and bathroom that apply only to room rental and don't apply to the yearly rental. I still want to be able to query seamlessly on that. Not only that, I want to be able to show, okay, give me all of the John Smith leases, whatever they are, John Smith leases, whatever they are, yearly or monthly or room or parking, whatever. So the question here is, how do I handle that? And the answer is that in most cases, I'm going to do that using a multi-map index. So let's look at Adam. Okay. So now this gives me this. Notice, by the way, that the query is very interesting. I'm searching for leaseholder equal to Adam. How can this work? Because I don't have a leaseholder named Adam. I have a leaseholder named Adam Smith. So what's going on here? For that matter, that's strange. What actually is happening here is that, let's go and look at the index terms. So what actually happened was that when I indexed the leaseholders, I told Raven to do that using full text search. So it broke it apart into individual items. Now let's see. Now we get into the more complex pieces. Okay, so I have a multi-map index, and I will show you exactly how it looks in a second. But now I need to query on that. But this is going to return me a room rental. This is going to return me a yearly lease. Those are typically different instances, different class types. So how am I going to work with that? For that matter, they have different properties. So the typical way I would do that is to do this. Project the shared set of fields. In most cases, so there are actually two ways for me to handle that. If I'm writing in code, I would do something like this. And this will give me with a yearly lease and a room rental. And the idea here in this case that RavenDB is going to generate polymorphic query, and this is going to work just like you would expect it. The other alternative is to just select the fields that I want and do that as a projection. In most cases, I would say that you want to do the projection. Something like this. Why do you want to do it as a projection and not as as a polymorphic operation, because if I'm doing this sort of query, in most cases, I don't want to do logical operations. I'm not going to run the payment schedule or something like that, which may require me to get to apply different logic per concrete class type. Instead, I probably just want to render that to the user. So that's something that I might want to do, and it would be much easier for me to handle that by just doing the projection. Now, let's go and look at this index and see how it works. And this looks like a very complex index. But if we ignore this, then just for merely this, just on this, for room rental, just this. When we are building a multi-map index, one of the requirements that we have is to make sure that we have the same set of fields across all of them. In many cases, in this case, this is trivial, but in other cases, I may need to adjust the shape of the documents. For example, I might have a requirement that says, okay, do I allow pets? But this one does not have allow pets. So we'd have to do something like that. I'm not sure how valid that particular example, but the idea here is that you have to understand this behavior, that they have to have the same set of fields. Now, I'm actually going to show you a brand new features right now. Let's go look at the documents. Here is the lease agreement. And because they are renting a room, they have a shared Excel with all of the features, all of the expenses that they have. Now, what I want to do, I want to be able to query not just on the content of the RavenDB document, but also on the content of the attachments. And let's see how that works. So you can see that I'm saying, okay, give me all of the docx or XLS attachments on this document. I load the attachment, get the stream, and then I'm saying this thing. Office, get portex, get exetex. I'm not sure what this means. This is something that comes from here. By the way, you can see list holder documents are marked as full text search. This comes from here. You have this office. And here is the code to handle that. And it's actually easier to look at just the Word one. Open the word processing document, do all of this. It's a trivial amount of code. But where did we get this from? This is coming from here, from document format. But where did we get this from? This is coming from here. RavenDB now has, this is for 5.1, and this has NuGet integration. That means that you're able to specify packages like this and work with them. And in this case, it means that we're able to query So I want to search for Mary Jane, and I get to this guy. And here we go. Full text search in matter of seconds on the office documents that we have. For that matter, let's search for school. Pass gets us to expenses. And okay, that's Okay, I know what the problem is. And no, here we go. Sorry. I actually download this from the web, and apparently TLS and SS is different. And here we go. Subway pass, all bunch of other stuff like that. And now we have, in just a matter of, I don't know, 20 lines of code, 24 lines of code, the ability to do indexing on Office documents, the ability to index over object hierarchies, and things are just working. It's easy, it's nice. Okay, Mike Prager is asking, in your example with the list agreement, isn't the point of inheritance to maintain the common fields between inherited types? So can you explain why projection is better than just returning the base type? I'm not sure I understood. Okay, so the issue is here, whatever we're going to do this or this. Now, the idea here is that you're not going to get the base type here. You're going to get a list of the base type. So it's actually list of. And then you're going to get it instance of yearly list and then instance of monthly list, etc. Now, why does it matter? Few reasons. First of all, in many cases, this is going to be much bigger than what you need. And in some cases, the cost of getting that, deserializing that, and then only using those few fields doesn't make sense. Because if you're writing a query like that, in most cases, what you care about is just this. Show me the results in some grid table, send it to the user, those sort of stuff. Where is the idea of the class hierarchy become really interesting? When you have not just different data containers. So let's talk for a second about the modeling of inheritance. Because if I just had simple data container, I can do just this. More fields like that. In this case, the idea here is that I contain the list-based properties in each one of those. And alternatively, I would have something like this. Which may be yearly, room, etc. And then all of the properties. It wouldn't make sense. And from a data modeling perspective, it would be just as efficient to have it this way. You wouldn't have different collection. You would have something that is very nice to work with. When we start talking about inheritance, we have to talk about, okay, what are the different behaviors that I want to apply? And for example, I may have a list dot, I don't know, notify on renewal, which has different behavior around whatever your room rental or yearly or those sort of things. For example, for room rental, maybe you have to give notice on 30 days, and with yearly lease, you have to give for 60 days, but that's easy, that's data. What happens if I have different behaviors? For example, notify renewal may mean that for the room rental, I can just send an SMS. For yearly lease, I have to send a certified later, those sort of things. In that case, in order to model the difference in behavior, I might use inheritance. But in this case, if I just want to show you some details, why do I need to bring all of the different classes? Why do I need to get all of the data, which may be quite expensive? I can just project the things that I want directly. I hope that this answered the question. Okay, great. Now, let's talk about this. We talked about that. This is actually quite powerful. I don't have a demo for that here, but you can use the same mechanism to also do things to PDF, to do things such as OCR analysis. I have a blog post talking about how to integrate machine learning into the RavenDB indexing process, all sorts of fun stuff. Okay, so let's compare that to SQL model. And I think that I already spoke about the isolated, independent, and coherent. But I think that the main difference between them is that documents tend to be rich. They tend to be much more complex, much more expressive. And that's because you can do that. The cost of adding this sort of expressiveness to your system is not that high. At the same time, a document tends to be very focused. The list would handle just the list operations. You would typically not see a property on the list that says list of packages arriving or something like that, because that doesn't make sense. Another major advantage, I think, of document modeling is that it's much easier to discuss them with the business, because you take a blank piece of paper and you write the data out, and this is how this is modeled. Versus with relational databases, you have all of those pieces in the puzzle that you have to bring together in order to create something meaningful. Now, there is also the other side. There is a tendency to try to push everything into a single document. And you have to be careful about it when you have unbounded collections. Then there is the other side when you have documents that are minuscules, just one or two properties that record some association. In those cases, a good example might be a transaction record transferring money from one account to the next. So you may want to write it as from to amount, which is possible, but in many cases, you would probably want to have something like that. A daily activity. And now something like this. And again, a lot of that depend on the way that you model the system itself. This is typically how people think about your system. Show me the action on a day or a month basis. Depending on the actual way the system behaves, maybe the money transfer is a hugely complex object. I have fields here for AML, anti-money laundering, know your customer, approval process, a whole bunch of workflows that happen behind the scenes that may not be visible to me. So maybe I do want to have something like that. But the whole idea is that we need, in document databases, a lot of the time you don't have this one true model. You have to work from, okay, what are the requirements that I have? Okay, now let's talk about big data. I got a question on that. And the interesting question is, what is big data? For that matter, what is big? Let's look here. Let's look at this data set. This is currently exceeding the half a billion documents. It is still going strong. According to my estimates, this is supposed to end with about 750 million documents, exceeding the probably exceeding the terabyte range. Now, this is running on a single RavenDB instance. And just to give you some idea, let's go and run query. This is the first time I run this query in a while. Let's run it again. Where subject is. Here we go. So interesting, actually quite interesting time to run this query. And now it's okay. So first time that I run these sort of queries, and then they take 0 time. And so when we start talking about that, the question is, what is big data? And the typical answer for that is that big data is data that is bigger than what you can conceivably put on a single machine. Now, just to give you some idea, this is a 1.4 terabyte disk. That's not a big, that's not too big. I mean, I can go and buy this sort of disk for $150. I can go on the cloud very easily to 16 or 32 terabyte, just like that. Now, I'm not sure. So the thing that we typically tell our customers is that once you're past the 5 to 10 terabyte range, you probably want to think about not putting all of your data inside a single machine. By the way, obviously not inside a single machine, you have availability, but for now I'm talking about putting all of the database inside a single, all of the data inside a single database. And at that point, we have to start asking questions. Basically, I never want to update Java. So let's talk about what sort of questions we have to ask. First of all, why is the data big? Am I keeping track of historical data that I may not need? Maybe I can purge it out. By the way, why do I want to avoid working with big data? Any ideas? Because it's awkward. Any operation that I have to make on a data set that is that has hundreds of billions of documents is going to take a lot of time. I have here an operation that operates on 80 something, and it's going to run for a while. And all of that are things that if you have any sort of operation that are impacted by the size of the data, and you're going to have, that's going to be awkward. For example, going to backup this amount of disk space is going to be problematic for me. It's going to take some time. If I have to run a report, well, reports, MapReduce handles that. That's not an issue. But in general, if I can avoid going to big data, I want to avoid that because I have far greater agility without this. But if I do have to go to big data, the first thing that I have to understand is, can I put it all on one machine? If so, great, that simplifies my life enormously. If not, then I have to consider, okay, can I split the data according to some business metric? It's very, very common for you to be able to say, oh, I already have these natural seams in my data. I have a multi-tenant system, and I can just split the data based on some based on tenant, and each tenant is not too big. That gives you a really great option. Beyond that, you have to consider the way that you think about the data. One of the things that RavenDB is very good at is having data flows. So for example, let's say that I have a lot of tenants. Each one of them is doing some, let's say, let's talk about, again, games. I have lots of users who are playing games, and I have a history of all of these games. I want to be able to run queries on the total to give you the ability to say, okay, show me the leaderboard of who is winning, who has the most results, or sort of things. In this case, the thing that I would probably do is to say, okay, I'm going to have, let's say, 5 databases, and this is doing manual sharding, by the way. RavenDB is going to have sharding in the 6.0 edition. We actually have the design for that ready. And if you have the time and inclination, I'm going to put that link in the chat. Go and read this. It's quite big, and it goes into all of the details about how we are intended to build sharding. For now, I'm not going to be discussing automatic sharding using RavenDB, but how you manage that manually. And manually, you're basically going to say, okay, user ID based on that goes to database 127, whatever, and then I'm going to store all of the games there for that particular user. In each one of these databases, I'm going to define a MapReduce syntax that would compute the leaderboard on that particular database. And then I'm going to define ETL to take all of those leaderboards and push them into a central location. So even though I have the data split into multiple locations, I don't really have to think about that because RavenDB is responsible for merging all of them together in the place that I want. Okay. By the way, we are almost out of time. So if you have any questions, take them up now. The final thing that I want to mention is that RavenDB actually has more than just documents, and this should play into your modeling decisions. You can see here how we can use a time series to track XP gains over time. So then we can use that to show you, okay, here is your XP gains, and oh my God, you're spending a whole bunch of time on the weekends playing League of Legends or something like that. And this is about as complex as that. But once you have that information in this format, you can start doing things to that. You can say, okay, who has the best XP gain over this holiday period? Let's give them some level up, some magic, whatever, those sort of things. And now is time for questions. Mike is asking, going back to the example of indexing the Office documents and PDF, would you store the actual documents in RavenDB or outside, like in Azure? That's an interesting question. So let's see here. A lot of that depends on what am I actually doing. In the example that I have here, the document itself is stored right here. And this assumes that RavenDB is the system of record for those documents. That would typically mean that when you open the list page inside your application, you have a list of documents in the side and you just access them. The good thing about that is that this frees you from a lot of the hassle. Oh, I need to integrate with SharePoint. I have to set up something else, all sorts of stuff like that. This is also good because RavenDB has features around, RavenDB has features around managing revisions, managing things automatically that you just utilize. Now, maybe you already have separate workflows around those documents. In this case, let's look here. And let's look at this, for example. Apparently, there is some Psychological fiction from when was that published? I don't know. Anyway, so you can see here that here I have a zip file. And in this case, instead of storing the actual content of the document, I'm storing just the extracted text that I'm interested in. In this model, I'm saying, okay, I still want to be able to search on the content of these documents, but I have other reasons why I want to store them externally. For example, I have workflow defined in SharePoint. For example, I don't know. Honestly, my gut reaction of saying SharePoint is thank you, no, but there are people who apparently find it useful. So if you want to store the data outside, then you would say, okay, I would run similar logic to this thing, extract the text that I'm interested in, and then just put it here and make it available for indexing. So those are the two options that I have in mind for that. But by default, I would put everything in RavenDB. That simplifies our life tremendously. Just the simplest example, you don't need to worry about how do I make sure consistency in backups. Things just work for you. Okay. More questions? By the way, a lot of you gave some really great suggestions for future webinars. If you have any additional webinars, topics that you want me to cover, feel free to send them. By the way, if you want to, you can also send emails to us directly. I will answer them. If I can either answer you directly or give you, or we will schedule a webinar and handle that. We also do demos that if you want us to talk to you about your specific scenario, those sort of things, you can go to live demo right here, ask for that, and we will set this up. And of course, just a reminder that you can also try RavenDB yourself in RavenDB Cloud. You can get started for free and just run with things. I think that we're out of questions. So thank you very much. Have a great day and goodbye. Bye-bye.